Yes, good evening guys to all of you on India's wonderful and largest e-learning platform Gradeup. And guys, today is the second session of this fundamental series and today's heading is method of joint. But we are going to learn about some wonderful things like what is perfect truss. We are going to know about the zero force members and from which every time the questions are coming. So guys, I hope you guys are ready for the session. Pradyuman, good evening. Sagar Moria, good evening. And I once again welcome you all. Ajay, good evening dear. Okay, so without wasting your time, we will be starting the session. And hope guys, yesterday's session you loved it. And now we are going to start the second session. Any doubt if you want to ask from yesterday's session, your doubts are most welcome. And yesterday I shared the PPT and today I will be sharing the previous year's gate questions with you from mechanical, and day after tomorrow I will be sharing for civil and XC as well. Mahavir, good evening. Suparno, good evening. Tejaswini, good evening. Okay, Rishi, yes, good evening. So let us start the session guys. So we will not waste the time. This is my profile, around 10 plus years of experience, and today's subject is engineering mechanics. And guys, this is the detail about vision batches. For vision 22 English batch, vision 22 Hindi batch, 423 batch. This is the contact for admission related query. Yes, good evening Abdul. And guys, tomorrow I will be taking a session where I will be telling you about the best combination of branches of gate papers to be taken. Okay, as you know, you can give two papers. So I will be telling you the benefits of XC, benefits of PI. Then you can choose wisely that which branch, which gate paper you shall go for as an additional paper. Okay, so guys, now we are starting with the perfect truss. Before going to method of joint, we must know about the thing that is said to be perfect truss. Yes, Sandeep, hello dear. So Shubhadeep, Mondal, yes, thanks for your wishes. Okay, thanks guys. So let us start now. So guys, when we are talking about the perfect truss, my dear, perfect truss is something which is having the number of members such that which are just enough for the truss to be in equilibrium. That kind of truss is said to be a perfect truss. A perfect truss is found to be statically determinate mathematically, and guys, it is a non-collapsible type. So I will be telling you the meaning of all these three members, and I will also be telling you what is the meaning of statically determinate and what is the meaning of non-collapsible. So my dear, a truss which is having the number of members such that it will be in equilibrium. That is the first thing we are talking about, the definition as perfect truss. So my dear, when we are talking about equilibrium, yes, Mulkraj, good evening. Let us say if you are going to make a truss, let us say this is one member, this is second member, and let us say we are going to make a hinge joint here and a roller joint here. Okay, so if this is, I am saying, let us say these are two members, this is AB and this is BC. You know my dear, if I will be applying a force, let us say some force F is applied onto this. So you know, if this distance is X, obviously when this force F is applied, maybe these supports are providing some reaction, and because of that reaction the body will be in equilibrium as per the forces are concerned. But you know, this force will also be creating a moment as it is at a distance of X. That moment will not be balanced by any of these two supports, because my dear, you know that when we are talking about these supports cannot give any moment reaction, and if they will be applying a force like this, then my dear, you know, there is no horizontal force. So for vertical, reaction can come only like this, and when reaction will be coming like this will be creating a moment. So this body is not in equilibrium, so we cannot make a truss using two members. So to have a truss, minimum number of members required are going to be 3. Minimum members should be 3. Now obviously the body is going to be in equilibrium, and you can say minimum number of members required are nothing but 3. And that is the reason, my dear, whenever you see a truss, it is made up of a combination of triangles. It is always made up of a combination of triangle. Now my dear, every time we cannot check like that. If let us say we are having 20 member, 22 member, 15 member, every time it is going to be very, very difficult to check like that. So some mathematical conditions were given. So as I said, the perfect truss is having one condition, that it is statically determinate. So now the word statically determinate have been seen in a great detail in the strength of material. Yes, Tridev, Nishant, good evening guys. So you know very well that what is the meaning of statically determinate. If the number of equilibrium equation and number of unknowns, if the number of equilibrium equation and number of unknowns are going to be equal, this condition is said to be statically determinate. So my dear, when I am saying a perfect truss is a statically determinate, then my dear, in a statically determinate truss, the number of unknowns are equals to number of equilibrium equations. Is it fine guys? So now my dear, we are going to see how many number of unknowns are there. You know, in trusses every member is a two-force member. So every member is a two-force member. It means either the member will be under tension or the member will be under compression. So it means my dear, every member will be having one force, which may be tensile, may be compressive in nature. So if we are having number of members to be M, can you tell me in M members? Yes, if one member is subjected to either tension or in compression, that member will be having a force obviously. So if we are having M number of members, there would be necessarily M number of forces for sure. Yes, Shivam Vahi, namaste. Sir, we did in Somna, sir, that moments was opposed by forces. Then Ajay, it is opposed by forces, that is correct. In strength of material, when you are talking about beam, it was a beam and two supports. Whatever I made is not that beam. Whatever I have made, that was not the beam. If you have this kind of connection, my dear, that is not in equilibrium. Who said it is in equilibrium? If you are applying a force on this like this, it will be moving about this point. This is not the beam in equilibrium. This will be moving when you will be applying a force onto this. About this pin, it is going to rotate like that. This is not the equilibrium condition. But when we were using strength of material, at that time beam was in equilibrium. In SOM, the necessary condition is equilibrium only. So there we were talking about that. Okay, Shivam, yes, Shivam, fine. Okay, Ajay Wall, yes, this was the point. Now I am coming on to my point. The number of unknowns. So my dear, the number of members are M. If the number of members are M, they are going to be the number of unknown forces as well. Number of unknown forces, because you know every member is going to be either in tension or in compression. So if M are the number of members, M are going to be the number of unknown forces, and we need to find out the force in each and every member. So if there are 5 members, there will be 5 unknown forces. If there are 7 members, there are 7 unknown forces. If there are 10 members, there are 10 unknown forces. So if M are the number of members, M are going to be the number of unknown forces. Then my dear, you know what was the best combination of support? 2 roller or 2 hinge or 1 roller with 1 hinge. What was the best combination of support? Yesterday we have seen 2 rollers, 2 hinge or 1 roller and 1 hinge. What was the best combination? 2 roller, 2 hinge or 1 roller and 1 hinge. What was the best combination guys? 1 roller, 1 hinge, 2 roller or 2 hinge. What was the best combination? I am asking again and again. What was the best combination? Yesterday we have seen there were 2 roller supports, 2 hinge support, 1 roller, 1 hinge support. Yes, I am waiting for your answer guys. Yes, 1 roller and 1 hinge support was the best combination. And my dear, 1 roller support was having 1 reaction. You know, 1 roller support was having 1 reaction and 1 hinge support was having 2 reaction. Here there was 1, here there was 2 reaction. So total, my dear, if you see the number of reactions to be equals to 3. The number of reactions to be equals to 3. Number of unknown reactions. Number of unknown reactions are equals to 3. So if I ask you what are the total number of unknowns, there are M forces and 3 equation. So the number of unknowns are M plus 3. The number of unknowns are M plus 3. The number of unknowns are M plus 3. Number of unknowns are M plus 3. So my dear, M plus 3 are the number of unknowns. I am telling you how the equation is coming. So these are the number of unknowns. And my dear, now you know that whenever we are going to have a truss, let us say we are having a truss like this. We are having a truss like this. This is a truss. So you know that this point is a joint. 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 This point is a joint, and let us say by searching all those joints 1 2 3 4 5, you know all the forces are acting on joint. So 1 2 3 4 5, a total number of joints here are 5 joints. Okay, so let us say J is the number of joints. You know that, my dear, whenever we are talking about any point, let us say this is a point, let us say one force is acting here like this P. So you know that whenever we are going to consider a joint, then if you are considering this joint D, let us say, so on this D there is a force acting as P. Obviously this member will be either in tension or in compression. Let us assume that member to be having a force in tension. So obviously you know that this kind of force will be acting. Let us say this is the force DC. Similarly, my dear, this member will be having a force, let us say FDB, and let us say this member is having a force of FDE. Can you say at any joint all the forces are coplanar and concurrent? Can you say at any joint the number of forces whatever are acting, they are coplanar as well as concurrent? If you remember, whenever I was teaching you equilibrium on Mechanical Marvels channel, I taught you that if the forces are coplanar and concurrent, then my dear, there are two equilibrium equation. One is summation fx0, one is summation fy0. Do you remember it or not? Whenever the forces are coplanar and concurrent, then there are two equilibrium equation. One is summation fx0, other is summation fy0. So my dear, if you are asking about for any joint, my dear, the number of equilibrium equations are 2. The number of equilibrium equations are 2. Those are nothing but summation fx0 and summation fy0. So my dear, every time, every joint will be having two equilibrium equation, summation fx0 and summation fy0. So my dear, if every joint have two equilibrium equation, there are total number of joint is J. So my dear, if one joint have two equilibrium equation, then I will be asking you J joints will be having how many number of equilibrium equation? Parvinder, yes, namaskar dear. So if one joint have two equilibrium equation, then J joints will be having how many number of equilibrium equation? My question is as simple as that. So my dear, if one joint have two equilibrium equation, J joints will have how many equilibrium equation? It is simply unitary method. Yes, it is going to be 2 times of J. It is going to be 2 times of J. So my dear, if you want to write generally, the number of equilibrium equation, it is 2 times of J. So my dear, when you are going to equate them, it is going to be M plus 3 are the number of unknown, 2J are the number of equilibrium equation. This is the mathematical condition for a perfect truss. This is the mathematical condition of a perfect truss. So my dear, if a truss is perfect, it must satisfy this equation, and that's why this condition is said to be necessary condition. That's why this condition is said to be necessary condition. That's why this condition is said to be necessary condition. If you remember Cauchy-Riemann equation in mathematics, you have studied one is necessary condition, other is sufficient condition. So if a truss has to be a perfect truss, it must satisfy this equation. If this is not satisfied, then truss is not at all a perfect truss. That is for sure. But my dear, now let us see the converse is true or not. If let us say this condition is satisfied, then can we say the truss is perfect? My dear, it must satisfy the sufficient condition, and sufficient condition is truss should be non-collapsible. Now we need to understand what is the meaning of non-collapsible. Non-collapsible का मतलब मैं आपको अब समझाऊंगा एग्जांपल्स के साथ. बहुत बहुत ध्यान से समझिएगा. ये इक्वेशन हर कोई पढ़ा देता है, बट इस इक्वेशन का मतलब हर कोई नहीं समझाता है. Let us say we are having a truss like that. We are having a truss like that. It is a roller and hinge support combination. Let us say this is. So if you are talking about the number of member, this is 1, this is 2, this is 3. My dear, the number of members are 3. number of joints 1, 2, 3. It is going to be 3. So my dear, when we are going to have the number of members to be 3, the number of joints to be 3, so you know that left hand side, when you are going to find out, the left hand side will be m plus 3, it is going to be 6. And if you are going to find out right hand side, whenever you will be having 2 times j, it is again going to be 6. So left hand side is going to be equals to right hand side. So you can say this is going to be a condition of perfect truss. But my dear, if you are talking about this is necessary condition, what is sufficient condition? Sufficient condition is if you are going to apply with some force at this point, F is applied, then under this force, this truss is not going to deform. Any member of this truss is not going to deform, my dear, that is the sufficient condition. It means it is non-collapsible as well. It is non-collapsible because in theory of machines also you have studied that it is going to be a frame or structure, because on applying force it cannot transmit the motion. So my dear, it is going to be a part of non-collapsible, means it is not going to move. So my dear, it is going to be non-collapsible. Ye deform nahi hoga, ye move nahi hoga, motion nahi hoga, and that is the reason this is necessary condition, this is sufficient. So yes, now you can say it is a perfect truss. Necessary condition is satisfied, sufficient condition is satisfied. You can say it is a truss. Now let us say an example of 4 members, which in theory of machines we study. Let us say this is the case of 4 members. So my dear, if you are taking about this, let us say this is hinge support and this is roller support. When we are going to say the number of members, this is 1, 2, 3 and 4. So my dear, this time the number of members are 4 and number of joints. Here you need not to see the joints are binary, ternary or quaternary. You just need to check the number of joints. There are 4 joints. So my dear, left hand side is m plus 3, it is going to be 7. And my dear, right hand side is going to be 2 times of j, it is going to be 2 into 4, it is going to be 8. So my dear, first thing is left hand side is not equals to right hand side, and as left hand side is not equals to right hand side, even mathematical condition is not satisfied, even necessary condition is not satisfied. So you will say this is not a perfect truss, that is for sure. So it is not a perfect truss. So my dear, satisfying this condition do not guarantee you the truss is perfect, but non-satisfaction of this equation is guarantee you that yes, it is not a perfect truss. So my dear, it is not a perfect truss, but my dear, the condition when left hand side is going to be less than right hand side, it means when m plus 3 is less than 2 times of j, then my dear, this condition is said to be unstable. Unstable means if you are going to apply any force onto this, let us say you are going to apply the force onto this like this, so obviously under this force it is going to collapse like this. It is going to collapse like this, and you know it is a mechanism. So my dear, it is obviously will be getting collapse and it will be deformed, and this is going to be the condition as well. So neither necessary condition satisfy nor sufficient condition satisfy. Both the conditions are going to be not satisfied here. Is it fine? So deformation I have shown, it may be shown like this as well. That will be depending on the applied force, how you are applying. Is it fine? Yes guys, please tell me up to this everybody is clear or not. Yes, and quickly like and share the session to others as well. So this is the condition we have seen. And guys, as I already told you, truss we are covering on YouTube from 8th of September, means from Wednesday. On Gradeup app we are starting friction topic. So one by one every topic will be covered. Okay, very good guys, very good. So this is something the condition, and let us say now we are going to have, as we have seen, when left hand side is equals to right hand side, then it is necessary condition satisfied, and after that we have already seen there are some sufficient conditions as well. Is it fine? Yes. So now let us see. My dear, you know m is equals to m plus 3 is equals to 2j. So we can also write m is equals to 2j minus 3. So this is the condition for equilibrium and perfect truss. Yes, no doubt about that. If m is going to be less than 2j minus 3, then this condition is said to be not equilibrium and the condition is unstable, what we have just seen. Third, my dear, if m is going to be more than 2j minus 3, it means the number of members are over, the number of members are extra. So extra members whenever will be present, it is said to be over rigid. It means the number of members are more than the required members. So more forces can be beared. That's why the condition is said to be over rigid. So my dear, mind it, these three conditions in question of gate. They may ask you that which type of truss it is. So this is how we are going to work in the necessary condition. Now I will be showing you the cases where necessary condition is satisfied, but my dear, sufficient condition will not be satisfied. Then what you will be saying? Yes, Parvinder, deficient means only that it cannot bear the loads. It is going to move. Deficient means the same only. Okay. What is unstable, that is deficient. Okay. This is also said to be deficient. When you are going to apply the force, it starts moving. When on application of force, it starts moving. When on application of force, it starts moving. When on application of force, it starts moving. It simply means that it is a deficient truss. Is it fine, Parvinder Singh? Are you clear about this? Yes. So my dear, now I will be showing you some other wonderful cases which will give you the better idea. Let us say now we are having a member like this. Let us say this is the case, and here we are having one more member. So if you see the number of member 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The number of members are 5. The number of joints, if you see 1, 2, 3, 4. The number of joints are 4. So left hand side when you are going for, it is going to be m plus 3. So m plus 3 is 5 plus 3, it is 8. When you are going for right hand side, it is going to be 2j. It is also coming out to be 8. So no doubt, my dear, necessary condition is satisfied. And even when it is made up of triangle, then obviously on application of force, it is not going to deform. So it is satisfying the sufficient conditions also. So my dear, if it is made up of triangles, sufficient condition is satisfied. If it is not made up of triangles, sufficient conditions are not satisfied. So my dear, here necessary and sufficient, both conditions are satisfied. It is non-collapsible. So I will be saying it is a perfect truss. Now my dear, you mind it, for a truss to be perfect, one thing is m is equals to 2j minus 3, and second is equals to, it should be made up of triangles. I am showing you one example where it is satisfying the necessary condition but not satisfying the sufficient condition. So I am showing you that. Let us say we are having a case like this. This time, this is the condition. And my dear, here is one member. And we are also having one member here. So my dear, if you see this time, this is member 1, member 2, member 3, member 4, member 5, member 6, 7, 8 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my dear, these are the 9 members. My calculations are okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So members are 9. If you are saying m plus 3 is the left hand side, it is 12. If you see the joint 1, 2, 3, 4, 5, 6. The number of joints are 6. So right hand side will be coming out to be 2 times j is equal to 12. Please tell me, do you feel that necessary condition is satisfied? Yes, left hand side is equals to right hand side. So you will say that necessary condition is satisfied. But my dear, can you tell me one thing, that whether it is made up of triangles or not? You can see, if by chance the force is applied here, it is going to deform like this. So it is collapsible. And if it is collapsible because it is not made up of only triangles, I will say it is not a perfect truss. It is not a perfect truss. Guys, are you clear about this or not? Please tell me that this thing nobody will teach you. They will be just telling you the condition left hand side is equals to right hand side. It is a perfect truss. But guys, for truss to be perfect, it should be non-collapsible, but it is collapsible. And if the same truss I make it like this, just feel I will not be changing the number of members. If I make it like this, the same number of members I am using. If you see, the number of members are not changed. 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of members are 9. Joints are still 6. 1, 2, 3, 4, 5 and 6. The number of joints are 6. So left hand side is m plus 3 is equals to 12. Right hand side is 2j is equals to 12. Left hand side, right hand side equal. It is made up of triangle. So my dear, it is non-collapsible as well. So my dear, if it is made up of triangle, it is non-collapsible as well. So we will say necessary condition, sufficient condition. So it is a perfect truss. It is a perfect truss. So it is a perfect truss. So guys, please tell me now, will you be able to see? Will you be able to check whether the truss is perfect or not? Is it fine, guys? Is it fine, guys? Everybody please tell me that. And quickly like and share the session, guys, with others as well. I want more and more people to study, because we are going to cover complete engineering mechanics, some topics on YouTube, some topics on app. In this month only, we will try to complete the subject. And we will be going in depth, whatever the maximum is possible. Everybody clear or not? Yes. Bharat Ajay, very good. Mulk Raj, very good. Sahil, very good. Pridev, very good. Ajay, very good. Muhammad Hassan, Sandeep, very good. So guys, did you get something new or not? Because majority of you have studied engineering mechanics somewhere. Did you find something new or not? Did you get something new or not? Then only it is beneficial to go for such a series. Because you and me both are investing time here. And time is very important. So you must learn something new. And that is only my satisfaction. Okay? Yes, great, guys. So this is how we will be checking whether the truss is a perfect truss or not. Two conditions should be checked. One is m is equals to 2j minus 3. Second is it should be non-collapsible. How to check non-collapsible? It should be made up of triangles only. Hari, good evening, dear. Ganesh, just refresh it if it is not working for you. Repeating whole will take time. I feel now we are moving to next topic where this topic is not going to be required. Okay. Next हम जो आगे बढ़ रहे हैं उसमें पुराने का कोई यूज नहीं है. So let us move further, guys. Now we are going to, my dear, that is zero force member. And after this only we will be starting the method of joint. Okay, after that we will be starting the method of joint. Thanks, Ashwani. So guys, when we are talking about the zero force member, as we have just seen, sometimes the number of members are more than required. If the number of members are equals to the number of members required, it is going to be perfect truss. But sometimes we are going to add some extra members which are not required. They are just extra members. So those members may not have any force into them. Such members are said to be zero force member. What is the requirement of these members? My dear, first thing, sometime loads may get changed. So we are going to make a possibility that in the future, if some extra loads will be coming, then those extra member will be taking that loads. One thing. My dear, second reason for those members is, as you already know, that the member of trusses will be either in tension or in compression. And the compression member may get buckling. So to avoid the buckle failure of those members, we are going to apply the extra member so that those buckling could be prevented. So for these purpose, we are going to add some extra members. And when these members are not having the forces, they are said to be zero force member. It doesn't mean that it is meaningless to have them. They are used for future use or to avoid the buckling. But it is not that zero force members are not required. No, it is only that zero force member don't have any force at the time when you are talking about them. And my dear, whenever you have a question given It may be very difficult when you look it for the first time. But after going for the zero force member, my dear, this question may reduce to very simple problem. So that is why before starting method of joint, I want to give you what is the identification of zero force member, so that before starting the problem, you can remove them, so that your work becomes very easy. Once you will remove the zero force member, it will reduce in the number of members. So when less number of members will be there, it will be very easy for you to solve it. So that is why we are going to identify the zero force member. So there are 3 rules for identification of zero force member. Just look at it carefully. They are going to make your work very easy. I will be showing you some wonderful gate question as well. So my dear, when we are talking about zero force member, my dear, if you are having two non-collinear members, let us say there are 2 members, this is member 1, this is member 2. They are 2 non-collinear members. You can see 2 non-collinear members. And my dear, at this joint there is no force acting. Then my dear, both these 2 members are zero force members. Both these 2 members are said to be zero force member, because when you will be applying the equilibrium here, you will be saying summation fx0. Summation fx0 will give you the force in this member to be 0. Let us say this is f1 to be 0. When you will be going for summation fy0, it will give you f2 to be 0, because in y direction the component of this force will be coming. So you will directly say f1 is 0, f2 is 0. So my dear, if you want to say that if there are 2 non-collinear members and there is no force acting on this joint, then both the members will be acting as zero force member. I will be showing you the examples, don't worry. Second condition, my dear, if there are 3 members, 1 member, second member and third member, out of these 3, 2 are collinear, this and this are collinear. If there are 3 members acting, there are 3 members joined at a joint, and out of these 3, 2 are collinear, and there is no force on this joint, then third member is a zero force member. So if it is first member, it is second member, you will say it is third member, f3 is equals to 0. Don't worry, I am going to use it in a wonderful question. So f3 will be 0. My dear, if there are 3 members out of which 2 are collinear, then my dear, this third member will be a zero force member, and in these 2 members forces are going to be equal by using the equilibrium condition. This is how we are going to use it. I am moving to the third condition, and now all the 3 we will be using together. If there are 2 non-collinear members at a joint and an external force is acting, my dear, if there are 2 members, there are no non-collinear members, and force is acting, which is acting in a direction of one of the member. Let us say this is force R. Then if this is member 1, this is member 2, then my dear, F1 will become equals to R and second member will become a zero force member. This is the third condition, and my dear, these 3 conditions are given in every book. Now I will be giving you the fourth condition, which is not given in any book, that if you are having one member like this, other member like this, and we are having 2 forces to be applied, Rx like this and Ry like this. Let us say this is member 1, this is member 2. Then by equilibrium you can directly write F1 is Rx, F2 is Ry. This is rule number 4. We will be using all these 4 rules when we will be starting the method of joints. Guys, please tell me up to this point all the rules are clear to you or not. I am showing all the 4 rules in the upcoming questions. By looking at those questions, you will be solving them like this. I will be telling you how to reduce a 10-member problem into 3 to 4-member problem. Then tomorrow we will be solving it by method of joints. maybe if today time permits, one question we will do today as well. So method of joint, then method of section, then wonderful question. Yes, Ashwani, Hari, Bharat, Sahil, Pradyuman. Yes, thanks Suparno. Great, Ajay. Fine guys, fine. So guys, now I am showing you the question. Let us say this is a question. Find the zero force member. Nowadays in the question, in the paper directly they are asking the zero force members. So my dear, if you see this, let us say how many places we are getting zero force member. If you see this, at joint D, there are three members, AD, DF and DC. There are three members. Out of these three, these two are collinear. And there is no force at D. Can you tell me which member will become the zero force member? Very good, Parvinder. Which member will be zero force member out of these three? Which member will be zero force member out of these three? Which member will be zero force member out of these three? Very good, Suparno and Parvinder. Yes, first of all, CD is zero force member, because if there are three members out of which two are collinear, then my dear, there is no force at joint, then third member will become a zero force member. So when this member will become zero force member, then if you see now, the same condition is there with the GH as well. So GH is also the zero force member. The same condition is there with the GH as well. HB, and they are going to be like that. And similarly, my dear, now we are moving to the joint number C. At C joint, there are two collinear links, CE and CA. And this is one more link, because this link is already zero force member. So if you see this third link, they are two collinear members. There is no force on C. So it is damn sure that this is also a zero force member. And similar to CF, GF is also a zero force member, because at G the same thing is going on by symmetry. After CF and GF will become zero force member, at joint F these are two collinear, and this will become zero force member because there is no force on joint F. So this entire figure will be reduced in a triangle like that, where we will be having this as hinge support, this as roller support, and we are having a force of 75 kilonewton. So this is reduced to this triangle EAB. So this is the reality of this truss. Very good, Tejaswini, very good, Bharat, very good, Mulkraj, Pradyuman, Sagar, Education Adda, Parvinder, Sahil, Jacob. Wonderful. So this is how we can reduce such big members into such small triangles. Why I have taught this before? Because I want to reduce the question into easier one, then we will be solving it in a wonderful manner. Then my dear, let us see one gate question. How many of you give the right answer for that? Let us see. I am showing that. Okay, this is the question of method of joint we will be solving tomorrow. Yes, this is a gate question. What if we have load at point D? Then what about, dear, if load at D will be 0, if load at D will be there, Ashwani, then CD will not be a zero force member. Then CD will not be a zero force member, then CF will also not be a zero force member. All zero force member will become non-zero. Okay, yes. So the member ln of the truss is subjected to a load of, you need to tell about ln. Yes, this is a gate question. You can see, if you are talking about point L, there is no force, there are three members, this and this are collinear. If this and this are collinear, it simply means there is no force on L, it will become zero force member. So when it will become zero force member, my dear, then this figure will be reduced into this. This figure will be reduced into this. This is going to be like this. My dear, even the things are not going to stop here. Things are not going to stop here. At point N, once again they are collinear member. So this will also become a zero force member. And you will be left with a triangle once again. Like that. So this is how we can reduce a member into this. Everybody, please tell me, are you getting it or not? So today we have discussed two wonderful concepts. One was that when a truss to be a perfect truss, and second we have seen that how to find out the zero force member. Okay, there is one more question. There is one more question. Okay. This is one more question. So for this, how many members are zero force member? This is also an examination question of previous years. The members carrying zero force in the truss shown in the figure for any load P more than 0, with no appreciable deformation of the truss, with no appreciable change in angle between the members. These are the options. Once again, you can see the condition. First of all, at point B, these are two collinear members. Okay, so you can find out what are the zero force member here. The same thing you can watch at this point. Okay, and when they will become zero force member, you can see the same thing at point G. Okay, so please tell me what will be your answer. Yes, very good. Parvinder Abdul Bharat, wonderful. You know that BF is going to be a zero force member, no doubt about that. DH is also going to be zero force member, no doubt about that. And after that, GC is also going to be a zero force member, no doubt about that. Yes. After that, my dear, if you see, this is going to be link CD and this is going to be link DE. This is a zero force member. They are two collinear members. Okay. Yes. What will be the answer? A or B? Some are saying A, some are saying B. Lot of confusion is going to be there. Yes, guys. So this is going to be your homework question. And I want the solution or answer, whatever you want to give, on Telegram channel. I am sharing this PDF there. Today's time is over. And guys, tomorrow we will be going for the complete procedure of method of joint. And after going for that procedure of method of joint, I will be solving a conventional question in front of you. Then I will be solving 6 to 7 objective question in front of you. And day after tomorrow we will go for method of section. And on 9th of September you are going to have a test of trusses. The test will be made by me, will be shared on Telegram channel along with the solution, and I want to see whatever the marks you are getting. Solution I will be sharing after one day, and before that you need to share the answers of that with me, and I will be going through your answers as well. So we are going to be in a nice manner, just like the batches are going on. Okay, so please tell me, are you fine with all this? Today, whatever we have discussed, are you clear about that? And if I ask you what are the two conditions for a perfect truss, how many of you can answer? One condition I am telling you, m plus 3 is equals to 2j. What is the second condition? I want to know that. This is the necessary condition. What is the sufficient condition, guys? Yes, Ajay, we will be trying to complete this in this month only. Yes, very good, Abdul. Very good, Abdul. Yes, परविंदर हो गया है, आप कर लीजिए. अच्छा, आप बता रहे हैं बाकी सबको. Okay, fine. Sufficient condition is Yes, it should be non-collapsible. And Parvinder, how you will check that it is non-collapsible? How you will check that it is non-collapsible? Yes, Mulkraj, it should be made up of triangles only. It should be made up of triangles only. Yes. So guys, here we are concluding the today's session, and as I said, tomorrow we will be solving these questions. Even I am showing you the questions which we are going to solve tomorrow. Okay, these questions we will be solving tomorrow, and some new questions will also be there. Okay, so this is the star faculty team of mechanical engineering, and guys, you can see every day we are taking the sessions on YouTube channel as well as on Gradeup app. These are the top 10 rankers from GATE 2021, and under Gradeup Super you are getting the structured live courses for GATE, for ESC, for PSUs, for research organization like BARC, and for all these test series are coming in green card. And guys, tomorrow there is a surprise for you, surprise session. Gradeup is going to be in a new avatar from tomorrow. That new avatar session will be there at 5 p.m. tomorrow. So mechanics session tomorrow may be at 6 p.m. because tomorrow 5 p.m. will be a surprise session for all of you, where you will be knowing about the new avatar of Gradeup. Okay, so this is going to be the contact for admission related query. And guys, just download the Gradeup app, start your preparation journey with us. So goodbye guys for this session. Thanks for your love and support. Do join on regular basis. I can guarantee you, you just pay some time and you will be becoming the master of engineering mechanics. That is my promise to you. So goodbye guys for this session. Thanks for joining once again. Thanks, Suparno.